So hello everybody, welcome to Counting in Probability number 6. We're still working with combinations, and what we're going to do is we're going to now use the formula to help us solve some problems. So what I'd love for you to do is turn to your textbook, page 625, so you can follow along with some of the problems. So the first problem I would like to look at is number 29. And number 29 says an election ballot asks voters to select 3 commissioners from a 6-person ballot or 6 candidates. And how many ways can you do this? So the first thing I want to do is figure out if this is a combination or not. And so I have 6 people, and I want to choose 3 of them to be a commissioner. Now those commissioners don't have any rank or priority at all, so I'm just choosing 3 out of 6, so order doesn't matter. So this is a combination. It's a combination of 6 choose 3, and therefore that's equal to 6 factorial over 3 factorial times 3 factorial, which is equal to 6 times 5 times 4 over 3 times 2 times 1. The denominator cancels with 6. We're left with just 5 times 4, or 20 commissioners, or 20 possible ways to select commissioners. So I should say ways to select commissioners. Okay? That's the first example. So in the textbook, problem 33 says, you volunteer to help drive children at a charity event to the zoo, but you can fit only 8 of 17 children present in your van. How many different groups of 8 children can you choose? And so our question then is to solve that problem. So this is going to be a combination of 17 choose 8. So I'm choosing 8 out of the 17 children. It's not a permutation because order doesn't matter in terms of once I select 8 children, they can sit wherever they want in the van. So it's not a permutation. So how do I solve this? Well, it's 17 factorial over 9 factorial times 8 factorial. The 9 cancels with the 9 in the 17 and less. So I'm left with 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10. And then 9, 8, 7, 6, 5, 4, 3, 2, 1 cancels over then 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so I got lots of canceling I do here. And so I'm going to cancel the 5 and the 3 with the 15. I'm going to cancel the, let's see, the 4 and the 2. I don't want to do that. Keep the 4. Let's go 2 and 8. Cancel with the 16. And then the 4 I'll cancel out of the, well, let me split the 4 up into 2 times 2. And we'll take one of the 2's and the 6. Cancel with the 12. And the other 2 and the 7 and cancel with the 14. So if you work it right, you can pretty much cancel almost everything. So my solution is just 17 times 13 times 11 times 10. And you can probably multiply that out by yourself in order to solve it. So when you have lots of canceling to do, you're almost always going to be able to cancel the denominator. But you might have to do what I did here on the 4 and split it up into 2 times a 2 and cancel it in 2 different places. Okay. So this takes us to the next set of problems, which in your textbook are on page 626, and they're numbers 36 or 37 through 46. And in these problems, the directions are solve by method of your choice. And so if you want to try and solve by the method of your choice, what that means is you're probably going to have permutations, combinations, and fundamental counting principle problems all mixed in. So let's go through a few of these so that you can see what they are. Open your book to 626 and we'll list them and see how we do. So let's look at number 37 first. It says, in a race in which 6 automobiles are entered, there are no ties. In how many ways can the first 4 finishers come in? So what I'm looking at here is a first, a second, a third, and a 4th place. And so I know I have 6 choices, then 5, then 4, then 3. Or if I wish, I could have looked at this as a permutation of 6, choose 4 at a time. Simplified, that'd be 6 factorial over 2 factorial, which if you follow the arrow all the way around is just 6 times 5 times 4 times 3. So 37 was a permutation. So why don't you try number 41? It says, from a club of 20 people, in how many ways can a group of 3 members be selected to attend a conference? So is it fundamental counting principle, permutation, or combination? Which one is it? That's right. This one's... Can you believe it? Can you believe it? I circled the wrong one. It's a combination because order doesn't matter. You're just picking 3 people to go to a conference, and it doesn't matter who you pick as long as they're picked. So it's neither of the first 2, it's a combination. And what is it going to be? Combination of 20, choose 3. And once you do that, then you can simplify that and solve the problem. So let's try another problem. So the one I picked is problem number 46. So problem 46 says, Baskin-Robbins offers 31 flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many bowls are possible? So each flavor is different, but does it matter if you have chocolate, strawberry, vanilla, or vanilla, strawberry, chocolate? The answer is no. So this one is also a combination, and it's going to be combination of 31, choose 3 flavors, which you can then calculate. So to finish up, as you can see, you're going to do a variety of problems where you want to solve these. All of them are generally combinations through 35, and then once you get to 37 through 46, you might have a few permutations or fundamental counting principle mixed in, although I think many of them are going to be just combinations. So good luck. We'll work on your assignment tomorrow, and we'll either do the odds or evens from 29 to 46.